Hi. So in this video, I will be going to explain about the working principle of PN junction diode and VI characteristics of PN junction diode. So let's we discuss about the working principle of PN junction diode. So if you see here, first diagram is the symbol of PN junction diode. So in PN junction, normally it is a two-terminal device. The one terminal is anode and another one is cathode. So here if you see the diode is one junction, that is PN junction, and two layer. Here P layer and P type semiconductor will act as in one layer, and another layer is N layer. N type semiconductor will act as another layer. So PN junction it is a two terminal and one junction device which is normally conduct in only one direction. So that is why it is called unidirectional device. So the PN junction diode is one of the simplest semiconductor, so which has the electrical characteristics of passing current through itself only one direction. So next we discuss about the working principle. So here the PN junction diode normally working in two condition. First one forward bias, next one is reverse bias. Here the forward bias means here we are going to connect this n-type semiconductor. Here we already earlier I have said there are two terminal, two layer, that is p type and n type region. Here the in forward bias, the negative terminal of the battery is connected to the n type semiconductor, and the positive terminal of the battery is connected to p type, that is p is connected to positive supply, n is connected to negative. If we connect like this, then the PN junction diode is normally working in forward bias. So once the voltage is, when we keep on increasing the voltage, this external battery voltage, so up to zero point 0.7 for silicon, then up to 0.3 for germanium. So there is no current flow in between p type and n type semiconductor. So that is normally in off condition. So once the voltage is beyond this voltage, then diode is starts to conduct. So normally this voltage is normally called as knee voltage or threshold voltage. So this potential is also referred as barrier potential. So when we keep on increasing the external source, so up to 0.7, so beyond the 0.7 only it starts to conduct. So up to 0.7 there is no conduction in this PN junction diode. So next one, if you see, next one is reverse bias. In reverse bias, we have to connect this opposite polarity, that is p type region is connected to negative and n type region is connected to positive. If you connect like this, then the PN junction diode will work in the reverse bias mode. So this is the VI characteristics of PN junction diode. If you see here, forward bias, so up to 0.7 voltage, there is no current, that is very minimum current, that is called knee voltage, so or threshold voltage. So here the threshold voltage means the voltage at which the device, that is PN junction, is starts to conduct. So until this voltage there is no conduction. So once we increasing the voltage after this knee voltage, then diode will conduct. So when increasing the voltage, the corresponding current also increasing. But in reverse bias, if you see here the reverse bias characteristics, so when you keep on increasing the voltage, there is no current, that is very minimum current, that is normally called as leakage current. So at one point, then the diode will gets breakdown, that is called reverse breakdown voltage. So at that time the current is will increasing maximum value, so it leads to damage the PN junction diode. So we have to work only in forward bias mode in PN junction diode. Next one is applications. So this PN junction diode normally used in rectifier circuit, clipping and clamping circuit, and voltage multiplier, and finally IM detector.